0.5. 0.585. Is that good? There? Is that making sense on that? Questions I can answer? Here, one more time. Okay, so back to this one more time. I want to make sure that number 3 is good. Anything else I can answer on number 3? Is that good? So I made that table. Feel like you can make those tables? That'll be one of those. All right, we're good. All right, on to number 4. So one town, 60% of adults have health insurance. Probably the 4 adults selected at random town all have health insurance. Round to the nearest hundredth necessary. Okay. What do you think? Confuse you by showing you both ways, probably. Hopefully not. So yeah, you could just think. So first off, you got to kind of get straight what they're saying. A lot of this is reading comprehension, isn't it? Really getting straight what they're describing. So what are they saying there? They're saying 66% of the adults in a town have health insurance. Okay, and what's the chance? What's the probability that 4 adults selected at random all have health insurance? They're really saying you ask 4 adults at random, and all 4 say yes, 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 yes. That's what they're saying, right? You grab 4 adults at random, and all 4 have health insurance. 4 yeses in a row. So really, it's the probability of yes, and yes, and yes, and yes. 4 yeses in a row. It's a big and question. And what do you always do with and?
Add, right?
Multiply. So or is add. So you really got to know or is add, and is times. I'll write that up for you. So the last problem we did was or. What right? Getting back here, would or defective, problem number 3. So we added the 88, 12, and the 17. That was an or problem. Now this is an and problem. And is multiply. Go ahead and put that right in your, I hope you're making your, adding to your study sheet right now. That exam 2 notes or whatever you're going to use during the exam. As we're going through this, add whatever is helpful to you. If that note's helpful, put it on right now. All right. So anyway, what's the probability somebody's going to say yes? If we ask somebody at random in that town, do you have health insurance? What's the chance they'll say yes? Yeah, 66%, right? Because 66% of the town has health insurance. If 66% of the people in the town, that means 66 per every 100, that portion of the town has health insurance. If we grab somebody at random from that town and say, hey, do you have health insurance? The chance they'll say yes is 66%, isn't it? Does that make sense? So that's going to be 0.66 times 0.66 times 0.66 times 0.66. And the quicker way is just go to the 4th power. You know that up arrow on the TI? I don't know where that thing is. Lower right corner, somewhere like that. There's an up arrow, 4th power. Hit the buttons on your calculator. You'll get answer A, 0.190. Is that good? Now the other way, let me show the other way real quick. You could do a binom. It is a binom, right? Because they either have the insurance or they don't. It's a 2-stater. A lot of these can be done with binom or another way. So if you're really good with binom. So is it, is it binom PDF or binom CDF?
PDF.
Well, is it an exact or is it like, because remember, exact is PDF and, greater, less, all those are CDF. So are they saying, hey, we want at least 4 people to say yes, or less than 4 people, or more than 4 people? No, exactly 4 people, huh? Exactly 4 people. So this is an exact 4 question. So it's binom PDF, huh? Because it's exact. And then remember how that worked? Number of trials, probability, and then exact number. I gave you that on your exam 2 notes. So that's going to be, what's the number? So it's going to be binom PDF, and then number of trials. How many times are we trying this little experiment? 4 times. We're asking 4 people, hey, do you have health insurance? Hey, how about you? Right? 4 times we're trying this. And what's the probability each time? 66. And what exact number do we want?
4.
We want all 4. Same answer. Just do it that way if you prefer. So that's actually pretty easy, isn't it? I was thinking binom. Sometimes binom is more tricky. That one's pretty nice. Either way. Is that good? Let's move on. If you're good, I'll move right on. 5. Okay, the random variable x is the number of houses sold by a realtor in a single month at the whatever real estate. Blah, 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 blah. Find the mean value of x. So you see how they have that? It says mean value right there, and it has these sigma things. What are we supposed to do? L1, L2, hit the buttons on the calculator. Right? You good on that? So just take this. Oh, and that's on your exam 2 notes somewhere. What number is it? Anybody have those? Is it? Oh, number 1. It's number 1 on the exam 2 notes. Right? It says that they give you a big table and they ask you if you're mu or sigma. So there we go. Just put this in L1. Put this in L2. Hit the buttons on the end when you're done. After you got them in, then you hit stat, calc, 1 var. And remember, you got to go L1, comma L2 whenever you have both lists, right? You got to go L1, comma L2 at the end, or if you have the fancier kind, L1 and L2 on the 2 different lines. And then hit enter. And then you look for the X bar, don't you? X bar is our letter. They're using a Greek letter, whatever. Number 5. So it's none of the above. So it must have been. When somebody got that one, what did it come out to be?
3.6.
Anybody else get 3.6? Yeah.
3.5.
Did it round to 3.6?
No.
Sounds like a couple people got 3.6. They want to check that again. So 3.6, but anyway, it's not up there. Right? It's not up there. It's none of these. We good there on that? All right. Shall we try number 6? 28-year-old man pays $181 for 1 year life insurance policy, coverage $150,000. Probability to live through the years. Bunch of 9s and a 4. What is expected value for the insurance policy? All right. So write on your exam 2 notes. I think it's number 2, right? I go insurance and gambling, which are all the same thing. Insurance and gambling, you guys are all quite familiar. We've talked a lot about those 2 things. So I give you the help there. So look at those exam 2 notes, number 2. And I say L1, you're supposed to put dollars of cost minus dollars to win. Wait, is it the other way? The win's supposed to come first, huh? Dollars win minus dollars cost. And then the second one is negative dollars cost, right? And then L2 is the probability of winning and the probability of losing. Okay, so that's what we need to do. So let's do that. So what is dollars win minus dollars cost? How do you win in life insurance?
You don't.
Right, you win financially if you die, right? You know, my dad used to always say, and he was right on the money, he used to always say, life insurance, what's that? You're betting you're going to die. Well, it's exactly what it is. You're betting you're going to die. So your family wins financially in that case, right? So, okay. So you win how much money? 150,000, right? Yeah, 150,000 minus what you paid for the policy, the 181. And then what's the probability that you're going to win like that?
149,000. Oh, this 1 minus.
Yeah, because the 0.99994, that's the chance you're going to live through the year. So there would be 1 minus that. And you can literally just, it's 3 9s and a 400. Just type it in just like that. You don't even need to figure out ahead of time what it is. Just let your calculator do that hard work. These calculators are awesome. They'll do everything. It's just knowing what to put in, huh? Okay, and then the second one, negative the dollars cost. So what's the cost of this? That's the 181. So that'd be negative 181. That's the cost to buy the policy. And what's the probability that you'll end up just paying that money and that's all?
0.999.
It's the chance that you'll live through the year. So literally, if you just type those 4 entries, just like they are there, you don't have to figure them out ahead of time. Just literally type those in. The calculator will calculate them right there and then for you. And then when you're all done, do the normal. Hit stat, calc, 1var, L1, L2, and then enter. And we'll get our answer, whatever that answer was. Minus 91. Oh, the X bar. You're looking for the X bar. Minus $91. That means, on average, the insurance company, you're losing $91 on average. Insurance company's making $91 per policy on average. Is that good on how to do that? Yep. So there'll be either a gambling one or an insurance one. So you might get a gambling one. Like you play the lottery and this and that, chance of winning, losing money. Right? We had one of those in the practice exam, didn't we? You've seen them both now. I think we had a gambling one in the practice exam and then a insurance one here. So I don't even know what the one you have is. I have several versions of the exam, but it's one of those. And there'll only be one. There'll just be one on the exam, on the real exam. We good? No questions? On with 7. Company purchases shipments of machine components and uses this acceptance sampling plan. Randomly select and test 30 components, except the whole batch if there are fewer than 3 defectives. If a shipment of thousands of components actually has 7% rate of defects, what's the probability this whole shipment will be accepted? Good job. Yeah, that's really good job to identify that right away. You all seeing that? That's a lot of the battle, isn't it, on these things? Yeah, that's a binom, right? Because there's 2 states. The items are good or bad, right? So for sure we can do binom. But then what kind of binom? A lot of times I've noticed over the years in teaching stats and other math classes too, word problems are challenging. Stats is all word problems. And all those words can be confusing. Let me help with that. A lot of times a good thing to do is start right from the final question and kind of work backwards. If you feel like all those words at once confuse you, it might help to start with the actual question and work back from there. So what do they actually want? In the end, it's a lot of information, and then comes the actual question. What is that question? Probability that the whole shipment's accepted. So probability that the whole is accepted. So what is the probability that the whole is? How does the whole get accepted? I'm trying to walk back a step. So they're asking me, find the probability that the whole is accepted. What makes the whole be accepted? Yeah, there it is, right? You accept the whole batch if fewer than 3 defectives are found. So that's really what they're asking me. Fewer than 3 defectives. Is that good? So that's really what they're saying. What's the probability you're going to have fewer than 3 defectives? So that's a binom. And so now we can go to your exam 2 notes. The binom is like number 3 on there. And I gave all the different examples to help out with how you do the binom, depending on, what if they say greater than, or more than, less than, at least, and all that stuff. So there's not the word fewer there, but there is some other word on that exam 2 notes. Are you looking at exam 2 notes number 3 there? That's really the same meaning as fewer. Less than, huh? Less than. You see that on the exam 2 notes? So on the exam 2 notes that I assume you're going to have with you on exam 2, Tuesday, part 3, one of them says, what is it, less than 4? That's the same. That's the same as fewer. Fewer and less are the same kind of thing, aren't they? So, and then I give, the example I give there, I end up writing binom, CDF, huh? CDF, and then number of trials, probability, and then what number did I put at the back? Did you notice? I put a 3. Yeah. Right? And so we don't have less than 3. We have we don't have less than 4. We have fewer than 3.
So it's 2.
So it's 2, exactly. Everybody seen that pattern? Yeah. Right? Whatever number's here, this is one lower. The reason, if you want even a deeper reason, it's because the calculator was programmed that whatever number you put in here, it does that number or less. So that's why less than 4 really means 3 or less. And in our case, fewer than 3 really means 2 or less, doesn't it? So we'll do binom CDF, number of trials. What's the number of trials? Well, number of trials. Yeah, it's going to be 30, huh? Number of trials, that'll be 30. And probability, which is the, 7%. 7% of them are bad. And then 2 or less. Again, you don't write in all those words. I'm just telling you why they're there, huh? Is that making sense then? So you can just follow the pattern off your exam 2 notes. Just less than 4, they pop in one number lower. So fewer than 3, we put a 2 there because it means 2 or less. That is what fewer than 3 is, 2 or less. Hit the buttons and you'll get it. And what's the answer there? See? 0.649? Is that good? Feel like that's okay? Questions I can answer on that one? All right, I'll move on. The number 8 here. In a survey of college graduates, 56% reported that they entered a profession closely related to their college major. 8 of those survey subject rounds selected was probably exactly 3 entered. So exactly 3. Binom. Yeah, we just grab on that phrase, huh? Exactly 3, and we just say, exactly 3. That's binom, and it's a PDF. Yeah, PDF, not CDF, just like the exam 2 notes tell you. It's all in their exam 2 notes. And then we go number of trials.
8 trials.
How many trials?
8.
8, yeah, 8. We surveyed 8 people, huh? 8, probability, 56%. And the exact number 3. Hit the buttons on your calculator. And it comes out 0.162?
Yeah.
So that one's the easy one, right? Pretty easy. Questions on that one? Okay, so we got the curve thing here. Find the area of the shaded region, blah, blah, blah. All right, area of the shaded region. What am I going to do to find the area of the shaded region? So we know all the normal, so if you're ever reading, when we read the word problems that say normally distributed or they show us a curve that's a bell, either way, going to use either normal CDF or inverse norm, right? For anything that's a bell curve or says normally distributed. So we see the bell curve, we go, all right, I'm either going to do normal CDF or I'm going to do inverse norm. Which is which? How do you know? When do you do normal CDF? What does it say in the exam 2 notes?
When I have low and high.
When they ask for a percent, an area percent, huh? Percent or decimal. Area percent or decimal. Inverse norm is when they give you an area percent or decimal. So it's all about, are they asking for an area percent or giving you? Now, the easy way to keep that straight is, remember, on all these graphs, the numbers on the bottom are not the area, are they? The area is always up here. Like if they told me 0.3712, that would be area. They're not telling me that. They're not giving me area. So this is actually a normal CDF. But right, are we good with that general idea? That'll make it comfortable, because areas are always at the top, aren't they? Areas are always up. Remember where these all came from? Remember when we first did one? I think the very first one I ever did was men's shoe sizes, or I could do like men's weights, right? Just make sure the reality is kind of with you. I think it'll make it easier. So like 180, 190, right? Average man weight 170. Then there's lower weights, and then you could have shading, and we could say 23. We could say 23% of all men weigh 190 or more. Right? So I just want to get the idea that the numbers on the bottom are measuring something in the real world. Weight, height, whatever. Blood pressure, whatever. And the numbers in the top are area percentages, aren't they? So this is 23% of all the men weigh 190 or more. So anyway, so numbers in the top are always percentages, and they're always areas. Numbers in the bottom are not. Okay, so the whole thing is, are they asking me for a percent or giving me a percent? They're not giving me percent, so they must be asking me for it. It's normal CDF. So I'm going to do normal C to F. Right on your exam 2 notes, it says left edge, right edge, mean, and standard. So, normal CDF. So what's the left edge?
0.59.
Yeah, that's the left edge of the shading, 0.59. What's the right edge?
9999.
Yeah, it goes right forever. That's the way we say infinity to the calculator, huh? If you want it, you can just type in 1,000,000 if you want to. There's nothing magical with the nines. You understand? I'm just typing in a really big number. It's just to the right forever, infinity, basically. You type in 1,000,000 if you want to. I just thought a bunch of nines was quick and easy.
Yep.
Mean is 0, standard is 1, right?
Yes, sir.
Hit the buttons, and we get B, 9B. That one. Is that good? Move on to, so I think that's probably good. I'll move. Double check your rounding. You probably rounded wrong. All right. So let's try. So then number 10. Same kind of thing. It's either going to be normal CDF or inverse norm. Which one is this one? Yeah. And how we know is because they're giving us an area, aren't they? Yeah. So it's got to be inverse norm because they're giving us area. They're saying that shaded portion is 0.0901. That they're just telling us that straight out. So then that's inverse norm, area to the left, mean and standard. So inverse norm, area to the left. So what's area to the left? It's that, huh? Area, by the way, this is the spot we're finding. We're going to find that spot by plugging in area left of that spot. So what's the area to the left of that spot? 0901. The mean is 0. The standard is 1. Hit the buttons on the calculator and get the B minus 1.34. That one okay? You comfortable with the normal CDF inverse norm? Okay. Suppose that replacement times for washing machines are normally distributed, mean 8.4 years, standard 2, find the replacement time separates the top 18% from the bottom 82%. So right away, how do we know right away it's going to be one of those normal CDF inverse norms? Percentage, and it, well, I'm even more basic than that right now. It says the word normal. So, right, because I've seen people, I saw somebody that took one of my other exams just yesterday, and she was frustrated. She came up to me in the middle of the exam. She said, Mr. Taryn, this is just not working on my calculator, da-da-da-da-da. And I looked down at her work, and the problem, it wasn't this particular one, it was another question, but it said normally distributed right in the middle of the problem, and she was doing a bunch of binom stuff. And I just looked at her and said, I'm sorry, you're doing it wrong. That's all I can say. I'll give you every bit of information before and after the test, but during the test, I need to know what you know. And so she was not keying in, and she's a good student. She's actually a really strong student. She was just missing those words, normally distributed. So don't miss those things, right? If it says normally distributed, it ain't a binom, right? Or anything else. It's normal CDF or inverse norm when they say normally distributed. So, all right, so we're thinking, all right, some kind of bell curve. You don't have to draw the bell curves. I think they might help. So I'll draw one. What goes right in the middle? The mean, yeah, 8.4. 8.4 goes right in the middle. And then, now, what are we going to do with the top 18%, bottom 82% thing? Yeah, it's good. Is everybody down? That's exactly it. Whenever they say top, that means to the right. And bottom, that means to the left. Is that good? Let me try to make this a little more real. I think the more real it is, the better it'll be. What this is talking about the average time your washing machine lasts before it needs to be replaced. Right? How many years does a washing machine last? I don't know. This problem is saying the average is 8.4. So better washing machines, or maybe washing machines that are used less, whatever, they last longer. Some washing machines last less longer or shorter, right? So that wasn't very well said, but you know what I mean. Anyway, so let me just put some longer times. You get the idea? So to the right is longer lasting times. You want a washing machine to last 10 years, 11 years, right? Those are further to the right. And to the left are the ones that don't last very long. Washing machine only lasts 5 years. That'd be kind of a bummer. I have to replace your washing machine. after 5 years. I'm always having to replace my tires. I feel like every time I go to America's Tire and have my tires rotated, they go, "Oh, your tires, you got about one more." And I'm like, "I just bought those about 6 months ago." They're like, "Yeah, I don't know what's happened." Anyway, enough with my tire problem. But washing machine, so that's how long it takes to replace a washing machine. And so they're saying to us that when they say top 18%, they're saying something up here. I don't know exactly what the number is, but somewhere up here so that this is 18%. Does that make sense? And why did I put that 18% at the top instead of putting that 18 down here? Because it's a percent, right? Percentages always go on the top on these normal curve things. You getting the hang of that? Always. Percentages always go in the top on these normal curve problems because they're representing area. The numbers on the bottom are not percentages. They're measuring something like men's weights, men's heights. In this case, years your washing machine lasts. It's how these normal curve problems will be all semester long. The bottom line measures something in the real world. The top are the percentages. Okay, so when they say top 18%, question?
So how did you know what to draw the 18%?
Good clarification, Jennifer. Yeah, I don't really know exactly how far to the right it is. Let me get rid of these lines even. I don't know. I just know the general idea that it's somewhere right of the middle and it's a percentage above, and they want me to find the spot below. That's exactly what they want me to find, is how many years puts you in the top 18%. Like if your washing machine lasts 12 years or longer, does that put you in the top 18% of how long washing machines last? I don't know. That's what we're going to try to find out. What is the number of years that you need to be in the top 18%? And they're telling me top 18% from the bottom 82%. So that means all of this is 0.82, isn't it? Okay, so is it normal CDF or inverse norm? Yeah, it's inverse norm because they're giving us area percentages, aren't they? So it's inverse norm. And for inverse norm, you always do area to the left. And what is the area to the left? That's the 82, right? Left of this spot. What area is left of that spot? 82%, huh? 8.82, mean and standard. So the mean is 8.4, right? That's the middle. The average washing machine life expectancy, and the standard deviation is 2. Because they vary, right? On average, they deviate by 2 years. Some last 2 years longer, 2 years shorter. Hit the buttons, and we should get answer C. 10.2 years. That means this mark right here is 10.2 years. That means if your washing machine lasts 10.2 years or longer, it's in the top 18%. It's lasting in the top 18%.
So then, like,
when do we do the 1 minus? If I didn't have this 0.82 here, if all they give you is area to the right, then I would have put 1 minus 0.18 here, which is the same as 0.82. They just happened to tell me both on this one. But good point, Jennifer. Yeah, so remember we have to put into inverse norm area to the left. Yeah, so it might be on the exam. I honestly don't even remember because different versions and some of the problems too. Sometimes they only give you area to the right. And like what if they had just said, "Hey, find the amount that separates the top 18%." Boom, and that's all they said was top 18%. They didn't say from the bottom 82. If they just said top 18, then yeah, I would have had to put 1 minus 0.18 because 18 is the amount to the right and I need left.
Because that's what I did. And
1 minus 0.18 would work great.
Yeah, okay.
That would actually work. No problem at all, because that is 0.82. I just went ahead and said, hey, they gave it to me, I'll just type it in. But yeah, no, that would work just fine. 1 minus 0.18. Good on that? So if they just give you area to the right, you need area to the left, so it's 1 minus that. So a bank loan officer rates applicants for credit. Ratings are normally distributed. What does that mean? A binom? No, when I see those words, I'm thinking it's normal CDF or inverse norm, for sure. Right? With a mean 200, standard 50, applicant randomly selected, find probability of a rating is between 170 and 220. Probably not a hard one for you guys, right? I think it's much easier than the washing machine problem. Draw a normal curve. The mean is 200. They told me right there. And then they're saying they want it between 170 and 220. Now, where's that 170 and 220 go? Are those percentages? No. So they don't go at the top. Percentages go at the top. They must go on the main line, huh? Is that getting more comfortable? That's what review is supposed to do for you, is make it more and more easy than it seemed when we first did it in homework. 170, 220, they want the area in between. So am I going to do normal CDF or inverse norm? Normal, because, yeah, they're not giving me any percentage. They want me to find the percentage. So that one's normal CDF, huh? Normal CDF, which always means left edge, right? What's the left edge? That's just the 170. Yeah, this is the left edge. This is the right edge, 220. Mean standard, the mean is 200. Standard deviation is 50. There we go. Hit the buttons on your calculator. And 0.381.
Yes.
You good? That one's easier than the washing machine. All right, so the main point with all these normal curves, percentages go at the top, other numbers go on the bottom. Non-percentage numbers go on the bottom. All right, so 13. Assume that women's heights are normally distributed. Mean is 60.6. Oh, by the way, we already read the key words, huh? Women's heights are what?
Normally.
Am I going to do a binom? No way. I'm going to do normal CDF or inverse norm for sure. With mean 60.6, standard that, 90 women slept. 90 women. 90 women. What does that mean? Group. Going to divide the standard deviation by square root of 90 at the end. So it's a normal CDF inverse norm, but you can't forget to divide by square root of 90 at the end of the standard deviation. That's the key, right? Whereas if they said individual woman, we wouldn't do that. So watch out for that.
So you divide before you put the answer, or?
Yes, before, yes. When you write in the normal CDF thing. Is this in normal CDF? Yeah, write in the normal CDF thing. I'll show you, I'll write it out. Okay, so I'm going to draw a curve. And the middle, what is the mean? There it is, 63.6. Standard there. 90 women, probably mean height between 62.9 and 64. That'd be like here. 62.9 and here. 64, they want me to go in between those, right? Mm-hmm. So that's we don't have any percentages anywhere, do we? So it's normal CDF, not inverse norm, right? Normal CDF. Okay, so it's normal CDF, and which is always left edge, right edge, mean, standard. But I'm going to have to go standard divided by square root of n because I have a group, not an individual. Right? That was the central limit there. Remember that dice thing I showed where when you did averages of dice, that pushes things to the center. So when you have group averages, you got to divide by square root of n. It makes less deviation. It pushes things to the center. So, all right. So what's let me put it down here. Normal CDF. Left edge. That's easy. 62.9. Right edge, 64. Mean is 63.6. It's in the middle. Standard deviation, where is it? Oh, 2.5. 2.5, but 2.5 divided by square root 90. Like that. Yeah, that's all you have to do. There's no nothing else. No 1 minus answer or anything. Just like that. That'll take care of it. It's answer A. It's 0.932. Coming out okay? That makes sense? You'll be able to remember the group thing? Because they'll give you both. On the exam, they'll be like individual, normal distribution questions, and group. Divide by square root of 90. On that. All right, 14. Suppose that replacement times for watch music sounds very familiar. Find the probability that 70 randomly. Okay, so 2 keywords need to jump off the page for you right away as you read this. There it is again. normally distributed. We know it's going to be normal CDF or inverse norm. And then 70 randomly selected washing machines. Is that one washing machine or a group of washing machines? It's a group. We're going to need to divide by the square root of 70. Again, it's just like the last one, huh? We'll have mean replacement time less than 9.1. Okay, so we're going to draw. So we're knowing it's going to be a normal curve and divide by the square root of 70 at the end of the standard deviation. Let's draw the curve. The middle is something. Oh, there it is, 9.3. 9.3. And what's their actual question? There it is, less than 9.1. So remember, so the last couple problems they said between. So I just drew the two things and shaded between, you know. This one says less than 9.1. So is the shading going to go to the right or to the left when it says less? To the left. Lower things are to the left, right? This is so, and 9.1 is like over here somewhere, and shade to the left, because less means shade to the left, huh? Is that good? If they said greater than 9.1, then I would shade to the right of the 9.1, wouldn't I? Then is it normal CDF or inverse norm?
Normal CDF.
No, because again, there's no percentages given anywhere, are there? There's no percentages there at all. So it's going to be normal CDF, which always means left edge, right edge, mean, standard, but divided by square root of n because we have a group. We're not talking about one washing machine. We're talking about the average replacement time for 70. You see, that's like a whole store saying, hey, what's the average replacement time for our 70 washing machines rather than just an individual? So that forces things to the center. Averages go to the middle, don't they? If you roll a bunch of dice, you're going to have high numbers, low numbers. The averages are in the middle. So it lowers the spread, divides the standard deviation. Okay. So normal CDF. Okay, so the left edge, right edge. Left edge of what? Right edge of what? The chunk that's shaded, huh? We're focused on that chunk that's shaded, this chunk right here. So what's his left edge? Yeah, here's his left edge, minus forever. You know, you can put minus a million if you want. It's just minus, it's just left forever, isn't it? So that's why it's negative, because, you know, negative numbers go to the, you know, like a normal number line, right? Negative numbers go to the left, positive numbers go to the right, like just a normal number line. So when the shading goes left forever, we just go negative a million or negative 99999. So that the calculator will consider that left forever. And then the right edge is right there. It's the 9.1, huh? That's the left and the right edges of that chunk of shading. Comma mean is 9.3. Comma, now the standard deviation 1.1, but divided by square root of 70, huh? Because we have a group. All right, hit the buttons on your calculator. Oh, and it's, I don't know what it is. It's
0.0641.
0.0.
It's none of the above.
Yeah, so it's none of those. 0.0641, did you get that?
Mm-hmm.
It's kind of disturbing, isn't it?
Yes, it is.
Some of them are none of the above. What's up with 15? What we even supposed to just use your graphing calculator to generate a normal quantile plot for this data. Yeah, just put it all straight down L1, right? Just put all that data straight down L1, and you'll get a graph that doesn't look like A or B. The answer says C, so I'm just assuming. Did the dots come out sort of like that?
Yeah.
Came out okay? You could tell which answer it is and everything? Just a little tedious to type them all in, huh? Isn't that good? But in some ways you might prefer those questions. There's nothing too tricky. Just put them in and hit the buttons. Is everybody's calculator set up to do that?
Uh-huh. That's why I get a little iffy.
Yeah. Batch of 8,000 clock radios, 2% are effective. Sample 11 randomly selected without replacement from the 8,000 and tested. The entire batch will be rejected if at least one of those tested is defective. What is the probability that the entire batch will be rejected? Ooh, it's a lot of words, isn't
Yeah.
it? That's what's hard, yeah. So that's a lot of the challenge in this class is to pick off the keywords, huh? And on this one, a good place is to really start with the actual question, because it's a bunch of information, and then the actual question kind of comes at the end. So what's the actual question they're asking us? What's the probability the entire batch will be rejected? So,
Or the percentage of what
yeah,
we do.
probability, the batch is rejected. So I would just start right there. I think that's helpful. Just start from what they want, bottom line, and then kind of unwind from there. Kind of work backwards from there. Ask yourself, okay, they want me to figure out the probability the batch is rejected. What does it take for the batch to be rejected? What will make that happen?
If at least one
At
is
least.
defective.
Oh yeah, right there. Good reading. Yeah. The batch will be rejected if at least one of those tested is defective. Good reading. So batch rejected, that's the same as at least one defective. At least one defective. At least one defective. So, okay, so we're down to there, right? We good so far? Just kind of took the bottom line question, probability of rejected, and then went back out and said, okay, how do you reject? They said it right there. It's rejected if at least one is defective. So now we're saying, okay, so you're really asking me to find the probability that at least one is defective. So how do you do at least one defective? Yeah, so there's two things you can do. On your sheet, your, what's it called, your exam 2 notes, number 6 on the back. Yeah, we could do binom is one of the ways. And then also number 6, I just directly wrote for you at least one. Remember, we had like half of one of our sections was at least one problems. So there will be at least one problem. Sorry, I'm just joking. On the exam, for sure there will be, because we had a whole, it was half of one of our sections was at least one. And I wrote out for you on exam 2 notes on number 6. So that might be, I'll do it both ways for you. So on the exam 2 notes, isn't it number 6? I gave help. Didn't I say at least one right there?
Yeah.
Yeah, so number 6, I'm giving you explicit help for at least one. And I said the way you do it is you just go 1 minus not whatever times not whatever, etc. That's all you got to do. Just 1 minus not times not times not times not, however many things you're grabbing. So we could totally do that. And then it can also be done with binom. I'll show both ways. So let's just do it this way. So 1 minus not. Now, it's one of the things you've got to be clear on, though, is what is it not of? Because it could be different things. I mean, it's always the same thing, but you got to be able to tell. It's not whatever they're asking for. What do I mean? What do they ask for? Well, when I write at least one here, I really mean I got it from this phrase, at least one defective, huh? At least one defective. So we're trying to figure out at least one defective. So that's what you put in the not phrases. Defective times not defective time, etc. It's whatever you're trying to find the at least one of. We're trying to find at least one defective. So then you go 1 minus not defective, not defective. How do you know that? Well, I wrote on the example for you there, the exam notes. I said, what was it? Was it like at least one boy, girl? I can't remember.
Yeah.
Girl? One was it boy? Whatever it says, notice it's the same thing in the 1 minus not thing. I think it says at least one boy, and then I went down there and went 1 minus not boy, not boy. I didn't switch to girl, right? At least one boy, 1 minus not boy. Same thing, right? So at least one defective, 1 minus not defective, not defective, not defective. So that's how you do that. So then that's going to be 1 minus. Now, what is the probability of not defective?
2% of the experiment.
2% are defective.
98%.
So 98% are not defective, right? 2% of the entire batch. 2% of the entire batch are defective, which means 98% of them are not defective, huh? Is that good? So it's 1 minus 0.98 times 0.98, etc. Now, how many 0.98s? There's 11 of them. It's however many you're picking. So that's 1 minus 0.98 to the power of 11. You know where that power button is, that up arrow on the TI? And hit enter. And we'll get our answer, whatever it is.
0.1992.
0.199. Yeah, rounded to 3 places there. Does that make it? Now, I'll show the binom way also. But that's the way directly off the notes. That's the way we did a bunch of those at least one problems back in that section in chapter 4 where we were doing them. So it's just 1 minus not times not times not, whatever they're asking. In this case, at least one defective, so not defective, not defective. And so you had to go up and think, oh, 2% are defective, so not defective, 98%. Okay, let's redo it the binom way, because that'll work too. Everybody got that copied down? Needs that? So, if you're just getting really good with binom, you might just prefer to do binom.
I like this one.
Great. Binom. So we're still. Let me go back to the question. We're still trying to ask what's the probability of at least one defective. Right. That's still the same question. And binom. I have an example on your exam 2 notes of binom. Exam 2 notes. Number 3, binom. Well, the one where I say at least. Don't I say like at least 4? Yeah, at least 4. And then I give an example. It ends up being binom CDF. Number trials, probability. And then what I put here is 3. Notice this becomes 1 lower because it's 3 or less. And then you got to do 1 minus second answer at the end because it's the opposite. So it's a fairly complex binom, the at least ones are. So that's what's on your exam 2 notes, is that if you're going to do at least 4, you've got to do binom CDF, trials probability 3 or less, 1 less, and then afterwards you're still not done 1 minus second answer because you got to do the opposite. So that's fairly complex. How would I apply that to our particular question? This one. Well, I would say, okay, it's going to be binom CDF, number of trials. How many times are we trying this over and over again?
11.
That's 11. By the way, notice we never used that 8,000. They were just throwing extra numbers at us to trick us. Didn't need it. 11 trials, right? We're examining a clock, right? We're picking out one clock at a time, checking it. Is it good? Is it good? Is it good? Right? One at a time, like that. All right. Hilarious. All right. So number of trials 11, and probability each time. Now probability each time. Now what do we put here? Well, at least one defective. So we're talking about probably defective. So that's just the straight out 0.02. So this is easier in that sense. How did I know that? Well, because it doesn't say opposite or not or anything. It's just probability of whatever you're testing. We're testing defective. So it's just the straight out 0.02. Whereas the other method, you had to do not. So that's what made that 98%, not defective. All right. And then now, for at least 4, I put 3 or less. So for at least 1, I'm going to put 0, right? 1 less. See the pattern? It's always 1 less. Because that's the opposite of at least 1, isn't it? Right? You know what I mean? If I said, hey, if somebody said, Mr. Aaron, you got at least 1 coin in your pocket? If I said, no, I don't have at least 1. I don't have 1 or more. At least 1 means 1 or more, right? At the least 1, but could be more, 1 or more. Mr. Aaron, do you have 1 or more coins in your pocket? No. What does that mean? If I don't have 1 or more, I have 0. That's the opposite of 1 or more, isn't it? So what we're really doing is figuring out the opposite. So that's why at the end, then you'd have to go 1 minus second answer. Like that. And that should be the same answer in the end. Either way you want to do it. Binom, CDF, or the way it is on the notes with the 1 minus not. There's going to be an at least 1 question. Either way can handle it. You good? Questions on that one? Okay. One of the 981 subjects, find the probability the person is a non-smoker given it is a woman. Okay, so that's the key part there. Non-smoker, given woman. So probability, non-smoker, given woman. Okay. So the whole thing here is a given question, right? What do you do in a given question? What are you always going to do in a given question? The given becomes the denominator. Right? Are you good with that? I want to put that on your exam 2 notes. I don't think I put that anywhere.
Oh, that's the total volume.
Or maybe, I don't think I did. So the bottom is not going to be the total. On a given question, the bottom is the given. So that's what's different. That's what's unique. That's what you need to be aware of. On a given question, the bottom is the given. The denominator is the given. Why? Because you're saying, hey, I picked somebody out of this whole group at random, and I'm giving you the information. Hey, it was a woman. They're giving us that. We know that. It wasn't a man. It was a woman. Well, if we know it was a woman, then that limits the possibilities, doesn't it? It couldn't just be anybody up there. It has to be one of the women. So when you're given information, it narrows it. Remember I did that with a dice, and I said, hey, what's your chance of getting a 6 if I roll a die? Well, 1 out of 6. Right. But then what if I give you some information and say, hey, I got a number higher than 4? Well, then that changes it. If you know I got a number, if you're given the information that I got a number higher than 4, well, there's only 2 possibilities. Either got a 5 or a 6. It changes the denominator, changes the possibilities, doesn't it? So that's what given always does. So they say we're giving you the fact that it's not just anybody. It happened to be a woman. So it's one of these people, isn't it? It's got to be. So that limits the possibilities. I don't know what those all add up to be, those women. 312, 72.
It tells you the total right there.
Well, that's the total for the various categories. Oh, you're right. It's right there. I'm not even looking. It totally does. It's 464. Yes, thank you. I didn't look right. It is 464 total women. Correct. Okay, and what's the top? Non-smoker. How many are non-smokers out of that group? Just the 312, huh? Just the 3 out of the women group, 312 are non-smokers. Divide that on your calculator.
0.7672.
0.7672.
No, 0.672.
0.672.
It's not there.
Other people getting that, and it's not there. None of those, which is always a little disturbing. Good on that. So given becomes the denominator. It limits the possibilities. All right. Okay, 18. Following table, blah, blah, blah. So there's some information. If one of the 87 flights is randomly selected, find the probability the flight selected as Upstate Airlines flight is an Upstate Airlines flight, which was on time.
Just go up to Upstate Airlines on time, 43.
Yeah, sounds good.
And the total flight's 87.
Upstate on time, 43. That looks great. Over the total. There's no given here, is there?
No.
They never said, given that it was a late flight, or given that it was upstate, or podunk, or whatever. They never said that. So the bottom is just total, not given, because there's not a given. So it's 43 out of, I don't know what the total is.
43 out of 87.
Oh, 87? Okay, thank you. So it's just A?
Because if one of the 87 flights.
Oh, did it say that? I didn't read that. Yeah, you're right. You're right.
Flights,
Oh, yeah, it's right there.
It's only 87 flights. But
Good. Easy one. 19. All right. Per the table, blah, blah, blah. Test subject. What's probably the subject has the disease given the test was results negative. So given, there it is. That word's got to jump off the page for you. There it is. Given. So probability has the disease given the test came out negative. That'd be a bummer. The test came out negative, but they really got the disease. So what's the probability they really have the disease given the test result came out negative? Okay, so it's a given. So that means that's the denominator, right? Yep. So the given has got to be, it always is, it limits the possibilities. It tells you we're talking about somebody that had a negative test result. You're given that information. we know we're talking about somebody with a negative test result. So how many people had a negative test result? Those people, huh? Whatever 9 plus 312 is.
321?
321, yeah, right? Good so far? We know we're talking about those people because those are all the people that had a negative test result. They're giving us that it is one of those people. What's the probability that they have the disease? So it's just out, it's out of those people, so it's just the 9, huh? Out of those people, how many actually have the disease? 9 of those people. Divide that one on your calculator, and you get 0.028. Answer B. So that's a given. Good there? Okay, so question 20. So blah, 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 blah. And notice the hint I put down here. This was the actual exam. So it'll be that way on your exam as well. There'll be one question that'll say, hint, this is the doctor mistake example. This is like it. From class, make a table with positive, negative, disease, no disease, and start with a total population of 1,000 and go from there. So let's do that. So let's start with a table. And it says put positive, negative at the top. So positive, negative at the top. And disease, no disease on the side. Disease, no disease on the side. And then suppose that the total population is 1,000. Where's that 1,000 going to go?
Bottom right.
Yeah, bottom right, 1,000. Yeah, and why are we picking 1,000? It's just convenient, right? We're talking about percent. It'd be like if I said, hey, at the ball game, 80% of the people were wearing hats. And there were 100 people at the ball game. Well, that means 80 were wearing hats. Or maybe there's 1,000 at the ball game. If there were 1,000, how many was that? Well, whatever, 800. So anyway, right? I'm just throwing out a number. Because really it's all percentages. I don't really know there's 1,000 people who've been tested for cancer or the disease. Right? I'm just saying, for example, if we had 1,000 people, here's what it would mean. Right? That's all we're doing. So just to make the numbers easy for us. Okay, so they're giving us all those percentages. And those percentages are true for the thousands and thousands of people they test. But let's make it a nice, clean group of 1,000 and see how it bears out for a group of 1,000. So the first fact. So you just put the 1,000 down there, and then you start with the first fact. Suppose that 5% of the population are infected with the disease. So what do I do with that?
We multiply
Yeah.
times 0.05.
0.05 times 1,000 be 50 people.
This is the total of the having the disease.
Right, and that'll go right there. Does everybody see what happened there? 5%. Okay, careful not to make that 0.5. It's just easy to do that little stuff, right? It's 0.05, right? 0.5 would be 50%. 0.05 of is times. Do you remember that? That's always in math. Of is multiply. So 5% of is 0.05 times, and it says the whole population, doesn't it? It says 5% of times the whole population. So 0.05 times 1,000. 50.
The
50
rest
people have
of the
disease.
population have no disease, which is the 950.
Yeah, now we can get the next section here. We can get how many people do not have the disease out of the whole population. What are we going to do for that? Just going to subtract, huh? Yeah. So to get that spot right there, it's just 1,000 minus 50 is going to be 950, huh? 950 do not have the disease. Good so far? Now we're ready to go on to the second fact. So we get the number and the subtraction. We'll do that for each of these facts. Next fact is 70% of those who have the disease test positive. So you got to be a little careful there. Notice it's not saying 70% of the whole population, like the last one did. The last one said 5% of the whole population. This is saying 70% of those who have the disease. Not 70% of the whole population. 70% of those who have the disease. So you're going to take 0.70 of is still times, but times who? Not times the 1,000, huh? Not times the whole population. Times the what?
50.
Times the 50. Times those who have the disease. It's saying 70% of those people test positive. 70% of the people that really have the disease test positive.
It's 35.
35 people. And where do I put that 35?
Positive disease.
Yeah, positive disease.
And then the negative will put the 15. So we can
Yeah. So then we can do the subtraction thing. 50 minus 35, that's got to be 15 to total to 50, huh? Let's put that in there. That comes from 50 minus 35. Okay, one more fact.
8%.
However, 8% of those who do not have the disease, again, not of everybody, not 8% of 1,000.
It's the 950.
Yeah, it's 8% of those not having the disease. Not 8% of the whole population, but 8% of those not having the disease. So 0.08 of is still times those who don't have the disease. How many don't have the disease? 950. 950 don't have the disease. Those are all the no disease people. And what does that come out to be?
76.
76. So 76. And what do? They test positive.
No disease positive.
Yeah, so right there. No disease positive. And then we do the subtraction thing again. Right there would be whatever 950 minus 76.
874.
874?
Yes.
Thank you. All right, we got the whole table.
And then the bottom.
Yeah, we can add them, I guess, huh? If we add these up, 111, and add the other one up, 8,
9.
8, 9. Now we're ready for the question. We got the whole table put together. We're ready for the actual question. Where is the question? Oh, there's. What is the probability that a person has the disease given, it's a given, that the test is positive? Let me write this down. Probability has the disease given the test is positive. So it's a given. So we know the denominator is going to be what's given.
111.
Yeah, so they're given, we're talking about somebody that tested positive. Who tested positive? These people, specifically the 111. Everybody see that? They're giving, they're saying, hey, we grabbed somebody random, and they did test positive. Given that there's somebody who tested positive, they're one of these 111 people, what's the chance they really have the disease if they're in that group? That's the 35, huh? Disease, 35 over 111. What's that come out to be?
0.315.
Oh, is it 0.315? And there it is. Answer B. Remember, that's the mistake 95% of doctors make. They confuse the order of the given there. So...